The topic for this video is stoichiometry. The essential questions are what does percent yield mean, and how can you find the percent yield? Okay, so to find the percent yield, it really measures the efficiency of a reaction over the theoretical yield. So the actual yield is what you really got. Like you're in a laboratory, you do the experiment, you take the mass at the end, this is how much you got. The theoretical yield is what you should have gotten, which you would figure out using your calculations. And then once you divide it, you'll multiply it by 100 to get it into a percentage. So the reasons it might be less than 100%. It could be because the reaction reverses, and so it's in equilibrium. So sometimes the reaction goes forward, and then sometimes the reaction goes backwards a little bit. It could be because there's a side reaction taking some of the product if you have an extra compound in there to maybe help make the reaction go faster. It might actually react with some of your reactants. Or it could be just because you lost the product, making some small errors here and there, maybe not being as careful as possible in your lab and losing some of the reactants or some of the byproducts and things. So, to show you how you do this, we are going to look at this reaction, and we have 2.5 moles of P4O10 reacting with 2.11 moles of water, and that's going to give you 8.5 times 10 to the 23rd molecules of phosphoric acid. So let's say you did this in the lab, and it really only gave you 7.25 times 10 to the 23rd molecules of phosphoric acid. Okay, so you were supposed to get the 8.5 according to all your stoichiometry calculations, but you got this 7.25. What's the percent yield? So you take your actual, which is what you actually got, 7.25 times 10 to the 23rd, put it over 8.5 times 10 to the 23rd, and then multiply by 100, and that gives you an 85% yield, which in lab, in high school, that's not so bad. If the reaction had a 60% yield, how many molecules of phosphoric acid would be produced? So we're pretending that this 85% didn't happen and we got a 60%. So we take our total that we should have, 8.5 times 10 to the 23rd, and multiply it by 60%, which we change into a decimal, which becomes 0.6. And so that would mean we got 5.1 times 10 to the 23rd molecules. So that's another way to manipulate that equation.